The last topic that we'll cover is encapsulation, which is something that we see a lot in the real world. The most common way to think of encapsulation is as a way to keep something or things inside of a container. But in object-oriented programming, encapsulation actually takes on several key roles. Let's see what they are. Let's start with that idea of keeping things contained. Think of a jar filled with candy. One of the things that the jar is doing is keeping all of the candy in the same location. That way, when you go looking for the candy, you know where it is. It's the same with classes. In fact, this form of encapsulation is what allows classes to exist in the first place. Without it, all of the information that's in a class would be scattered all throughout your program, and every time that you wanted to make a change to a class, you'd have to search through hundreds, thousands, even millions of lines of code to find what you're looking for. That would be like having to search through every house in your town every time you wanted a piece of candy. How inconvenient. Something else that encapsulation does is provide protection. Sticking with the candy jar, not only does it keep the candy together, but the jar also keeps unwanted things, like those gross chewy chocolate log things that nobody likes, away from the good stuff that we do want. It does the same thing with classes. We don't want anything to be able to make any changes to our classes. After putting in all of that effort to make our knight just the way we want him, we don't want somebody to come along and turn his hair green or put him in a tutu. While there is some data that passes between objects, we want to keep the amount of data down to only what is absolutely necessary. For the most part, one object doesn't need to know how any other object works. It's a lot like how you don't need to know how electricity works in order to turn on a lamp. That's because the inner workings of the lamp, just like an object, are encapsulated. Whew! We've covered a lot of ground in these videos, but before I send you on your way to learning your first object-oriented programming language, let's take a look back at what we've covered. It all starts with objects and classes. Classes are made up of a name, attributes, and behaviors, and you need a class in order to make an object. Remember that a class is like a factory, and what that factory makes are objects. And just like a real factory, it can only produce the kind of object that it's designed to make. From there, we talked about base classes and subclasses. Subclasses inherit from their base class, just like people inherit traits from their parents. Every subclass needs a base class that it inherits data from. A subclass can't exist without a base class. Any class can become a base class, even a subclass. A base class can have any number of subclasses, but a subclass can only have one base class. Then it was on to polymorphism, which means many forms, and overloading. Polymorphism is what lets us do all kinds of different things to make unique objects, while overloading lets us take one attribute, but have it mean different things depending on what type of object we have. And we finished our tour of the realm with encapsulation. Encapsulation both keeps all of the data for a class together, basically allowing us to have classes at all, and keeps that data safe and hidden, so that no unwanted data can get in our class. Got all that? Good. Because now you're about to embark on a quest that will test all of your newfound object-oriented programming skills. A perilous quest that will take you through all 4 regions of the realm, where you will challenge the wizard, orc, elf, and knight to single combat. This isn't to be taken lightly, so feel free to go to the glossary and read up before heading out to battle.